We are in Precalculus. Today is November 13th, 11/13. Please put the date on your paper so you can just organize this in case you need to know that you're absent this day or whatever. All right, so vector basics. So we are on Unit 3. That means we have Unit 3 guide in front of us. Our Unit 3 guide, where does that live? It lives right. That's Precalculus. There it is. Unit 3 guide. So we have a lot of lessons in here. Each one of these colors is a different day. This is the first time we're doing a unit guide. So each of these colors is a different day, which means tonight we have 2 Khan Academy homeworks. Next night we have 1, and then the quiz. Today's Tuesday, so that means Wednesday is 3-2. Thursday is a quiz, you know that in advance, and Friday is 3-3 scalar multiplication with 2 homework assignments. After each homework assignment, so there are 2 tonight, go ahead and tell me what percent you get. You can say 100%, you can say 75%. It will color code it accordingly. Make sure that you're doing that every single time that you finish Khan Academy. I will try to remind you because it's the beginning of using online unit guides. 3-1, vector basics. What is magnitude? When you think of magnitude, a magnitude 7.2 earthquake, what are you thinking? Magnitude.
Sounds so familiar.
In math, when you think of magnitude, I want you to think of this, length. Write it down, length. Magnitude.
Oh, and then latitude is, no wait.
Latitude and longitude are not quite the same. Magnitude.
Wasn't there another one for magnitude? Like another, I could have sworn.
Maybe. So magnitude, usually the general understanding about magnitude is it's how strong is it? How much is it? And that is in mathematics how long it is. So the length of a vector will be the magnitude of it, how powerful the vector is. How long is it? All right. And then direction. So direction, that just affects the angle. Are you going forwards? Are you going backwards? Are you going to the right? Are you going at 30 degrees? Are you going negative 13.5 degrees? It's the angle. So when you put these two together, magnitude and direction, you get a vector. So a vector just has magnitude and direction.
What do you mean magnitude? Oh.
If I put them together, you get a vector. So there are a bunch of different ways to see a vector. If you see a vector graphically on the coordinate plane, or maybe if you're working for the Air Force or whatever, you deal with vectors all the time. It's just an arrow. So this arrow represents a vector. Whenever you see a giant arrow now, you don't think of an arrow, you say vector, because we are in Precalculus. So it doesn't matter which way it goes for now. Eventually I'm going to be formally defining how this goes, and by the end of this unit you're going to be like, there are so many things that affect which direction it goes, and I can do that in 5 different ways. From now, I need to say, let me check really quickly. Let's call this point the initial point. Let's write it down. Initial point. Initial, and let's call this the terminal. I start here, and I guess that's the simple word of saying that the start is here, the end is here. Has terminado, have you finished? It is the end point, the initial point. We're good so far? There's another way of notating vectors. So in geometry, we learn things like this. I'm going to do this off to the side. In geometry, we say, okay, we have line AB, or we have line segment AB like this. Well, there's a form for vectors, and that's something that you do need to write down, and it looks like this. This is going to be called vector AB. Vector AB looks very much like ray AB, and it is a ray, kind of, and, but it does end. It's really a line segment with an arrow at the end, but there's how you say vector AB. So we're not in geometry anymore, we're in Precalculus. So whenever you see this, say vector AB. So far so good? All right, so let's look at some vectors. I want to know if u and v, those 2 vectors, are the same. Obviously they have, well, they're not exactly the same because they have different initial points, and obviously different terminal points. But I just care about their magnitude and their direction. First of all, are they going in the same direction?
Yeah.
Yeah, they are. They're both going straight up, right? Now, what about the magnitude? Are Are the magnitudes the same or are they different? They're the same? Why?
Because their length is 4.
Yeah, they both have a length of 4, so they have a magnitude of 4. So yes, they're the equivalent. That easy. And it immediately gets super hard. Here it goes. Example 2. Now we have these two examples. So, example 2. Are these the same vectors?
No.
Are they equivalent? They're not. So it's going to be one of B, C, or D. So it's not A, obviously. They look like they're going in different directions. So option C says the same direction, and that's obviously not the case. They're not going in the same direction, so it can't be C. So it's between B and D now. We have to figure out what the magnitude is. If it's the same magnitude, it's B. If it's different magnitude, that means it's a different magnitude and direction. It's D. Okay, so let's think about why. How long is this? How do I calculate the length of diagonals?
It's 2.
It's 2.
It's 2. I mean 1 over 2.
1 over. So you're saying the length here is 1 over 2?
Because I'm doing the rise over.
Okay, so the slope. And the slope will affect the direction. And we already talked about how the direction is not the same. But what about the length? How do I figure out the length of each of these vectors?
By the x-axis.
Okay, yeah, so you can think about it in terms of the x-axis. So this length of u went over 4, and it went up 2. This one went, I can color code this correctly. This one went left, come on now, left 2, so it went negative 2, and then it had a height of 4. What you're thinking about now is the components, and I'm about to talk about components on the next page if we flipped over to the back. And that's a good start, but think of this as a triangle. If I think about it as a triangle, and I can go ahead and just draw some extra lines. If I think about this as a triangle, and it's a right triangle because of the way that I've constructed my lines, the way that I've drawn my lines. If this is a right triangle, then is there a theorem out there that tells me the length of the hypotenuse, the length of that diagonal?
So it would be, you would use the hypotenuse theorem.
The hypotenuse theorem. It's not quite called the hypotenuse theorem. It's called something else. It starts with a P. Pythagorean theorem. There it is. And what is Pythagorean theorem? Can you tell me what to write out here?
It would be a squared plus b squared equals c squared. Sorry, it's because I thought you were reading.
All right. So what should I write then? A squared plus b squared. What is our A? What is our B? And it doesn't matter. You can switch them interchangeably.
So it would just be 2 squared plus 4 squared.
Okay. What's 2 squared? What is 2 squared? Yeah, let's do 2 squared plus 4 squared.
4 plus 16, so it'd be 5. C equals 5.
Yeah, so 4 plus 16 is equal to c squared, and then that means 25 is equal to c squared, and therefore if I square root both sides,
No, it's not 5, my bad.
see, it is 5.
No, because it's 16 plus 4 equals 20.
Oh.
Yeah, it is 20.
So let's come back here. Let's say it's 20 is equal to c squared. And therefore, c is equal to
square root of 20.
Square root of 20. And that can simplify, but let's just leave it as square root of 20 for now. Simplifying radicals is not the lesson that I have in mind today. Square root of 20. What about this one? What about v?
It would be the same thing.
The same thing. Daisy, why?
Except,
It is the same thing. It is the same length. But why?
Because technically they do have the same height the same length magnitude.
it's the same numbers, but one of them is just.
Oh, well, yeah.
Yeah, it's just the fact that for that one, it can still be negative 2 squared plus 4 squared, and the negative 2 would just turn into a positive 4.
Yeah, exactly. Yeah, you're seeing that in the formula too. And so that kind of leads us to a shortcut, right? If I look at the x and y components, if I count 4 here and 2 here, this one should have 4 and 2 in any direction. It can be negative 4, it can be negative 2. As long as these two components are the same elsewhere, positive or negative, then they have the same magnitude. So you just really need to count. You don't really need to use Pythagorean theorem over and over unless you really want to. Does that make sense? That's a horrible question. I should never ask that again. But we'll see examples. So the answer indeed was B, actually, not D. They have the same magnitude, but they do have different directions.
It just looks like V is longer than the other.
Yeah, an optical illusion. All right. So let's look at the component form. So component form, you're looking at the x's and y's separately. X direction, and y direction.
Or, aka, Pythagorean Theorem.
Yeah, and those are separate. Separately. So they're each in their own component. You add the x's, you add the y's. So for example, if I'm looking to add x components and add y components, you don't add the x's with the y's. You only add x's with the x's. They stay the same. They're kind of like adding like terms. You add all the x's, add all the y's, but it's just going to be a number, so you have to keep track of which one is which. So let's just look at the x components. Let's look at the x components of vector A. Here's vector A, it's the yellow one. What is the x component of vector A?
Oh, so it has to be the same length and the same angle.
So I only care about the x component. I don't care about the y component at all. So what is the x component of A?
So 4.
Is it 4 or negative 4?
Negative.
Daisy, is it 4 or negative 4?
Does it really matter?
It does.
Why?
Because one of them is negative and one of them is positive.
It's annoying.
Is it positive 4 or negative 4 for the
Wait,
x
why
direction?
would it be negative?
That's what I was asking.
Oh.
Why?
I thought-
Because I'm starting here
But
and
it's-
ending here, I'm going left versus going right. Saying left or right direction does matter because part of the definition of magnitude or of vectors is direction. I need to know what direction I'm going in.
So
My-
So, negative.
It is negative 4.
it's really annoying.
Oh, I'm sorry that's annoying, but we're going to have to get used to it. What about D? What is the x component of D?
4.
4 and not negative 4, so D does not have the same x component. So it's not D. What about C? What is the x component of C?
It is 2. Negative 2.
It is negative 2, yeah. And then Daisy, do B for us. The x component of B is what? Negative 4. So you can choose as many of these as you want. It says choose all answers that apply, and there's only one, and it's B. So the correct answer is letter A, but it's the vector B. A little bit confusing there. Are we okay with this? Ask me questions now. This is the perfect time for it.
Wait, what are the same? Oh, okay. Yeah.
So components can be negative depending on if they're going left, down, or whatever have you. So far so good? Let's look at another type of example that I can ask you about components.
Oh no.
I have an initial point at negative 1, 3, so I start here at negative 1, 3, and then I end with my terminal point at 5, negative 2. What are the components of vector u? You're kind of writing them like this. So I say vector u, so I write my u with a line over it, my arrow over it, I should say, and that's going to be equal to something, comma, something. And usually with vectors, you go like this. Instead of doing parentheses, you go like this. Just to be fancy about it. You don't have to. You can use parentheses and be lazy. But usually vectors have those little caret symbols. The less than, greater than. Those replace our parentheses. So u has what components? What are the x components? Well, my x went from negative 1 to 5. So is it a positive or a negative? It's a positive, and a positive what, Daisy? How much did I go in the x direction? Positive what? Positive 4 like this?
Right?
Check with Rochelle. If she agrees, then I agree.
Is it just 5?
It's not 5. So you're going from negative 1 to 5, right?
Oh, it's 6 then, right?
It is 6, yeah.
Yeah.
The total distance that
I
you've gone.
forgot. It's negative 1. Sorry. Okay.
Yeah, you're good. And so Daisy, I'm going to ask if it's, actually I'll give it to Rochelle. You just did the last one. So Rochelle, if I'm going from 3 to negative 2, am I going negative or positive?
Negative 5.
Oh, you already know. Negative 5.
I did your.
Well.
Cool. Yeah, and if you always, if you're getting confused by these, you can always try to do a sketch. You could say, okay, I'm here at, and it doesn't have to be a perfect drawing. It can be a sketch. You say, okay, I'm here at negative 1, positive 3, so I'm roughly right there, and I'm going to 5, negative 2, so I'm going 5, negative 2. You can see, oh, in the x direction, I'm going positive. I'm going from here to there. In the x direction, I'm going positive, and then the y direction, I'm going negative, and it matches with what I have here. We're okay with this? That's all the notes I have for us today. go ahead and write your summaries. And then the homework is going to be on Khan Academy. Again, we have those two homework assignments, equivalent vectors and components of vectors.